Hi friends, welcome back. Today we are going to solve Codeforces problem nearest beautiful number. If you are new to my channel, I want to mention that my channel is dedicated to help people who are preparing for any Java J2 interviews or coding interviews. You will find a lot of helpful videos on my channel related to Java J2 interviews and coding examples. Those coding examples are taken from previously asked interview questions by big tech companies like Amazon, Apple, Facebook, Google, Yahoo, Microsoft, and many others. So if you are preparing for any Java J2 interviews or simply want to learn Java J2 concepts or preparing for any coding interviews, then this channel can definitely be helpful in your job interview preparation. So please subscribe to the channel. So let's go through the nearest beautiful number problem description first. So it is a simplified version of problem F2. The difference between them is the constraints. Okay, so you are given an integer n, find minimum integer x such that x is greater than or equal to n and number x is a k beautiful. So a number is called k beautiful if its decimal representation having no leading zeros contains no more than k different digits. For example, if k is equal to 2, then these are some sample numbers they have given us. These are k beautiful numbers. As you can see, only maximum two different numbers are there, right? 3 and 4, only 3 and 4 is there. Here only 5 and 0 is there. Here only 7 is there. So less than 2 is okay, but more than 2 is not okay basically, right? So maximum two different digits you can use here. As you can see, 5 and 0, here 7, here 2 and 1. So they are k beautiful numbers, and these numbers are not k beautiful because they are using more than two numbers, right? 1 2 0. So they are using three digits here. They are using 4 5 and 3 here, so three digits again, right? Here 9 8 2 4, so again more than two digits. So number is k beautiful if they have maximum k number of different digits used in that number, right? So the input, let's say the first line contains one integer t. Okay, that is number of test cases. So let's go forward. Each test case contains one line containing two integers n and k. So n and k is, for example, let's look at this one. So this is the n, which is the number, and k is 2, right? So in output we have to output x number. So the minimum k beautiful number which is greater than or equal to n, right? So that's what we have to output. For example, if you see this number, let's say if you look at 1, right? So 1, and if k is 1, then 1 is k beautiful, right? Because it only uses one digit and it is greater than or equal to n, right? So 1 is greater than or equal to 1, so it is k beautiful. Similarly, in case of 221, and if k is equal to 2, then 221 is k beautiful, right? So it is the smallest number which is k beautiful, right, in this case. So uh, in this case we have to use two different numbers, and we have to find out a number which is either equal to this number or bigger than this number. So as you can see clearly, this number is not k beautiful, right? Because it uses 1 7 8 9 and 0. So it uses a lot of different numbers, so in this number, right, digits. So we cannot, this is not a k beautiful, so we have to find out a k beautiful number which is greater than or equal to this number. So this one, as you can see, is the k beautiful number. It has only two digits, 1 and 8, right? When you combine this 1 and 8, this is greater than or equal to this number, right? So it should be bigger than this number, but this should be smallest in that way, right? It's bigger but smallest in bigger numbers. So this is the problem statement. So problem statement is pretty clear from this. So we'll just go ahead to a whiteboard to understand the problem a little more, and then we will formulate the solution and discuss the Java code. So as you can see, this is one example that we are taking here. This is one sample that first we will just look at what k is equal to 1 means, right? K is equal to 1. So here we want to find out a k beautiful number, right, where k is 1. So whenever k is 1, what we want to do in this case, it's pretty straightforward, right? So we will just compare this first digit, which is 1. So we want to find out a number which is bigger than or equal to this number, right? So bigger than this number, it is easy to implement, because we will just increment this by 1, right? So 1 is there, so we will increment by 1, so we will just make it 2, and all the remainings we will just put it 2. So 2 2 2 2 2, so 5 more 2's we will put here. So 1 2 3 4 and 5, so we will put all 2's here. So we just incremented it by 1. So now this one is a k beautiful number, right? This one is a k beautiful number where k is equal to 1. So as you can see, it only contains one number 2 to form this whole number, right? And this number is greater than this number that is given to us. So this is one case where k is equal to 1. Now we will think about, like, we will see another example that they have given us, right? This one we are seeing this example. So now in this case, k is equal to 2, correct? So I'll just copy this example and paste it here quickly. So here k is equal to 2, it is given to us, and this is the same number that we were discussing, right? So let's just make it big. So now this one is a little more interesting case. Now we have to use two different numbers, and we have to find out a number which is bigger than this number. So how like what logic we can use to solve this problem? So what we will be doing to solve this problem is we will just create two for loops, right? uh, let's say one for loop will go, let's say it is I, right? It will go from 0 to 9, right? And the another for loop will is for, let's say, j, right? J, and j will go again from 0 to 9, right? 0 to 9. And we will always, what we will do in these two for loops is we will take this I and j values, and we will combine the digits that we are looking at, and we will try to generate a number basically from these digits, right? A k beautiful number basically. For example, let's say we are looking at, let's say, 2 and 0. Let's say I is 2 and j is 0. So we will generate something like this basically. So as you can see, if I is equal to uh, let's say 0 and j is equal to 2, then it will generate something similar to this, right? 2 and all other are 0 basically, right? So similarly, if I is equal to 3 and j is equal to 0, in that case it will generate something similar to this, right? 3 and then all zeros basically, right? So because, and why this is k beautiful? Because it uses only two different numbers, 3 and 0. Here also 2 and 0, right? So basically what we are trying to do here is we are trying to generate all possible k beautiful numbers of this k means 2, using two digits basically, right? Here we use 2 and 0, here we use 3 and 0. So as you can see, 40 50 60 70 80 90, then we will go, then 211, then 311. So we will generate all numbers basically, as you can see, right? So 3 1, then 4 1, then 5 1, like that we will generate all possible numbers into and we, whenever we generate the numbers, we will keep these generated numbers into a tree set in Java, right? We will put these numbers into a tree set. So once all the numbers are generated using these two for loops, then what we will do is we will just use tree set has a ceiling method, right? Ceiling, ceiling. So ceiling method we will do, and we will just pass our this n, this number, right, into the ceiling method, because we want to get a number which is bigger than this number but the smallest, right? Bigger than this but smallest. So because as you can see, this one is the answer, right? So this is the bigger than this number but smallest number. So this number is, it will be generated and it will be kept in tree set using our logic, and then we can just use tree set ceiling method to get that number from our tree set, right? So this is the logic to solve this problem, the nearest beautiful number of Codeforces. So let's take a look at the Java code. So once you understand how we are going to solve it, it's not very difficult to understand the Java code. So the Java code, we will take the n and k. So n is the number that is given to us, and k is the the k factor of the beautiful number. So if k is equal to 1, then as I said, what we are doing here is we will just try to find out the next number, and we'll just generate the like next to the first digit, right? So we are just reading here the first digit. As you can see, this current is the first digit we are reading, and then first we will try to just append the the next the current with itself, right? But if it is not making the bigger digit, then we will try to add one more thing, right? As you can see here, basically here we will add 1 to the current, and then we will generate a number, right? So this is what we are doing. For example, here we are doing like 2, then all 2's basically. So that's what we are doing here. So so I'll just first show you this sample where k is equal to 1. So then we will go to the other case of the code, right? So let's just first execute this. So as you can see, oh, so sorry, I have to, let's take this example, right? Let's take this example first. So here is the example that we are taking. So if we generate this, then as you can see, all 2's are generated, right? So this is the next beautiful number when k is equal to 1, right? So only so only we have used one digit, right? Only 2 basically. So because k is equal to 1. Now let's go ahead and let's take a let's make k is equal to 2. Now let's take another test case, right, where k is equal to 2. So we will create tree set in Java, and we'll just of long, right, because it will generating long numbers. And we are doing the two for loops, 0 to n, I and j, and we will just pass I and j into a generate number method, and the n, which is the number that is input number, right? N is this number, it is given to us. So we have this generate number method, right? So generate method number will actually like first it will calculate, it will get the minimum and maximum from this x and y, right? So for example, if it is 2 and 1, let's say x is 1 and y is 2, then it will create the min and max, right? Because we want to use the mean and max when we are generating the number, right? So we will first get the mean and max, and then we created a string builder. Now while I is less than n, first thing is we will read the first digit of the given number, right? So 1 in this case, right? 1, we will read 1. So after that we will check if the 1, if it is greater than the max, right? Means let's say for example, if it is, let's say 4 is there, let's say first number, right? So we don't want to and max is equal to 1, then we don't want to do anything, right, in that case, because the number we will be generating, we want to make sure that we are generating a greater number, right? That's why if it is not generating greater number than our current number, then we will just return, right? Because we don't want to generate a number which is smaller than the current number. So that's what we are doing here. Then when first digit of given number is less than the minimum, right? So for example, this 1, right? So let's say 1 7 7 8 9 and 0, right? So first digit, let's say, is 1, and the number that we are trying, let's say the minimum is 2, let's say, for example. So now this current is less than the minimum, right? So current is less than the minimum, then we will just keep appending the minimum number basically, right? For example, in that case we will just keep appending 2 here. So now like 2 2 2 2 2 2, right? In this case, for example, right? If current is less than minimum, and then we will just, I'm just printing it to show you. Actually, I'll just remove these printouts later, and then once we generate the number, we will keep adding that generated number into tree set, right? So for example, in this case it will generate a number like this, basically all 2's basically, right? And then we will keep that number into tree set basically, right? As you can see, so generated number we are always adding into tree set here, and then we will return, right, after that. Otherwise, when the current is less than max, let's say the current is this one, when current is less than minimum, right, we are taking a look. Now if current is not less than minimum but current is less than maximum, then in that case we just create one string builder here object, and then we will put max here, right? Max number. So let's say, for example, let's just assume that our, I'll just change the color. So our let's just think for a second that this is 2, right? This is 2 and our mean is 1, so x is 1 and let's say y is 3. Let's say x is 1 and y is 3. So in that case what we do is we just first append 3 into string builder, right? So that's what we are doing here. We are appending the maximum and then we are appending remaining minimum, right? So minimum is 1, so we are filling out remaining places with 1 1 2 3 4 5. So 1 1 1 1 1, so we will fill all this with minimum and this is the max we will put, right? And why we are doing it? Because we want to get a number which is bigger than this number, right? So 311 is bigger than this number, so that's what we are doing. And then once we generate it, we can put it, as you can see here, right, into the tree set. So that's what we are doing here, and we are adding it into tree set. So we will basically generate all these numbers and keep it into the tree set, and at the end we will just like so we are keeping all the numbers into tree set here and we are into while loop, right? So while I is less than n, right? So I is equal to 0, so it will generate until it's less than n, right? We will keep incrementing I here, as you can see at the end of the loop. So it will basically generate all the numbers and keep it into tree set, and after that we will just use tree set ceiling method. So ceiling method will give us the number which is bigger than our current input number but smallest, bigger but smallest basically. So let's just execute this code quickly. So I am just to show you the generated numbers, I am just doing system.outs here. So you will see generated numbers also. So these are all generated numbers, right, that we generated. So as you can see, all are having only 2 digits now 20, right, 90. So all only 2 digits, 2 and 1, like that. So you can see all 2 digits are generated in and kept it into tree set, and here we once we do the ceiling we will get the correct output here 181111, right? So as you can see here, the correct output we are getting 181111, right? So similarly if we try this test case, now here we have to use 1 here. So beautiful factor is 1 here, k is equal to 1. So let's just generate this. So this is all 9s basically, right, generated when it is 1, all 9s here, right? So our code is working fine. So this is the way, basically this is the logic to solve this problem. So when k is equal to 1 is one case we have to handle, and when k is greater than 1, then we will generate all these combinations of 2 digits basically and keep it in tree set, and we will use tree set ceiling method to get the next bigger number than our given input number, right? So I think it's pretty clear now how to solve the nearest beautiful number problem on Codeforces. This is a good problem I felt, so I just thought that it's good to create a video. If you are new to my channel, there is a playlist on my channel called as Codeforces. It has a lot of solved Codeforces problem explained with examples and Java code. You can go through those playlists, and the videos. You will get a lot of different varieties there. Apart from this, I have a very big playlist I created about Leetcode and Leetcode solutions. So those videos are important in the sense that as there are over 200 solved coding problems which were previously asked by different big tech companies like Amazon, Apple, Facebook, Google, Microsoft, Yahoo, and many others. And those coding interview questions are important in the sense that they constitute varieties such as dynamic programming, graph problems, binary search tree problems, binary search related coding interview questions, as well as BFS, DFS matrix problems. So if you are preparing for any Java J2 interviews or coding interviews, you can go through those playlists. You will learn a lot there, and it will be definitely help you in your Java J2 interview preparation. If you find this video helpful, if you like the way it's created with whiteboarding and examples and Java code, then please give it a like. Also subscribe to the channel, because your subscription is really important for the channel to reach to more people who need help in solving coding problems. They can also watch these videos and understand how to approach different varieties of coding problems, what data structures of Java to use to solve different coding problems, because the main goal of the channel is to help as many people as possible in their Java J2 interviews as well as the coding interviews. So please subscribe to the channel. If you like the video, give it a like. If you have any questions, please put your questions below the description and share this video with your friends and colleagues. And thanks for watching this video.